Today in the workshop, we'll be working with the Wi-Fi Stepper, a versatile board for controlling stepper motors of all sizes. We'll learn what makes it work and how to use its web-based interface. We'll also see how we can run a script on a Raspberry Pi to control a stepper motor remotely. We're stepping without wires today, so welcome to the workshop. Hello and welcome to the workshop. Today I'm going to be doing a rather special edition of the DroneBot workshop in that I'm taking a look at a product that one of my viewers has sent to me. Now, my viewer's name is Andrew and he's got a company called Good Robotics, and this is the product. This is a Wi-Fi stepper motor controller. Now, as the name implies, this allows you to control a bipolar stepper motor over Wi-Fi. Now, the device is an ESP8266 for its Wi-Fi capabilities and a Power Step 01 module to drive the motor, and as such it can drive a very heavy duty stepper motor. It's rated up to 85 volts and several amperes, so you can drive a very big stepper. This makes this ideal for applications not only in robotics but for things like antenna movement, solar tracking, opening and closing remote doors and windows. It's a very versatile device. Now, it comes with a web-based interface that allows you to control every aspect of the stepper motor, and you can also do scripting, so you can use a Wi-Fi enabled computer and run scripts on it and automate the control of a stepper motor without actually having to be able to be connected to it. So it's great for controlling a large stepper motor in a remote location. Now, I should mention that the device I have is a preliminary release, and as such there are a couple of features that are still not enabled on it. By the time you see this, the crowdfunding campaign for this will be active on the CrowdSupply crowdfunding site, and the device that is going to be on the crowdfunding site will of course have all of the features enabled. Now, if you're not familiar with CrowdSupply, and I have to admit I wasn't that familiar with it as well, it's a really interesting crowdfunding platform. It uses the same principle as you've seen on other crowdfunding platforms like Indiegogo, but in the case of CrowdSupply, most of the equipment seems to be things that are of interest to people like us. Modules for robotics, things for people who work with Arduinos and Raspberry Pis. So the site is a really interesting site in itself. And so at any rate, what I'm going to do today is put the Wi-Fi stepper controller through its paces and see what it can do. Now, we're going to start off by taking a look at what components are included on this little board. So let's get going. So here are the details on the Wi-Fi stepper controller. The Wi-Fi stepper controls a single bipolar stepper motor over Wi-Fi. It is rated at up to 85 volts and 10 amperes, meaning even large stepper motors can be controlled. It has an easy-to-use web-based interface. It supports both Bash and Python scripts and has a JSON API. In current control mode, you can step down to 1/16 microsteps at very high torque. In voltage control mode, you can step down to 1/128 microsteps with very low noise. The Wi-Fi stepper has four major components: the ESP8266 Wi-Fi controller, a Power Step 01 stepper motor driver, an ATEC 508A crypto authentication module for security, and a MAX 15062 high-efficiency voltage regulator. Now, here are the connections on the Wi-Fi stepper controller. First, there's a 2.1mm barrel connector for power input. This can handle up to 50 volts. Next, a terminal strip. The bottom four terminals are for the coils of your stepper motor. The top two terminals are an alternate power input. It can handle up to 85 volts here. At the top, we have some Power Step 01 breakout pins. At the bottom are breakout pins for the ESP8266. There is also a reset button and some status LEDs. So now let's start experimenting with the Wi-Fi Stepper controller. So now that we've looked at the components of the Wi-Fi Stepper board, I just want to show you the board itself. As you can see, it's a relatively compact little board. It's a really good quality build. Here's the ESP8266 for doing the Wi-Fi. Its antennas on this side. Here's the Power Step 01 stepper driver, and you'll notice it's got a heat sink on it to dissipate any excess heat. The connector at the back with the screw terminals is used for connecting the stepper motor itself. The first 4 connections go to the 2 coils in the bipolar stepper, and the other 2 connections can be used as a power input for voltage of up to 85 volts DC. This barrel connector can also be used as a power input. That's the one I'm going to use in my test, and it can handle up to 50 volts. There's also a connector over here for power and these 2 male header pins in the middle. Now the male headers on either side are basically the I/O for the stepper. Down this side you've got the I/O connections to go to the ESP8266, and on this side I/O connections to go to the Power Step 01. Now if you flip the board over, there's a couple of places where you can make a solder bridge. What that is for is when you're running it in voltage instead of current mode, you can bridge this to get a little bit more current into the motor and thus increase its torque. Otherwise, the motors actually have these resistors over here which are being used primarily for current mode to measure the current. You can use it in voltage mode without doing that, however, which is what I'm going to do, but you'll get a slight reduction in torque, which is not really a big deal in the experiments we're going to be doing today. There's also a reset button on it over here, and a couple of LEDs over here to indicate power on and the status of the Wi-Fi, and also a flag. When there's an error, you'll get a little red LED that lights up. The flag is also displayed on the web-based interface. So now that we've seen the Wi-Fi stepper board, let's go and hook it up and put it through its paces. Okay, so to begin, I'm going to show you the test setup that I'm going to be using to test the Wi-Fi stepper. I'm actually going to be using both of my workbenches, the one I have on either side of my workshop. So let me show you what I have on this workbench over here first. I've got the Wi-Fi stepper itself over here. This is the circuit board over here for it. And I've got a stepper motor. This is a NEMA 17 size stepper. It's a 12 volt bipolar stepper motor. And I've got it connected to the Wi-Fi stepper controller. I've made sort of a little jig over here to adapt the connector so I can use the screw terminals. And I'm going to power this through the barrel connector instead of the 2 screw terminals over here. And so I'm using the 2.1 millimeter barrel connector, and I've got that going to the 2 power supply terminals on my solderless breadboard, and from there I'm just running some wires out to my power supply that I'm going to be using to power everything. Currently the power supply is in standby mode. I've also connected a ground connection to a ground rail on the solderless breadboard, and that's for some experiments that I'm going to be doing with the Wi-Fi stepper. Now, if we move to the other side of the room, you'll see over here I've got a computer. It's a Windows 10 computer that I'm going to be using to connect via Wi-Fi to the Wi-Fi stepper. But I've also got a second computer over here, this one. Now, this is a Raspberry Pi 3, and you might wonder, why am I using a second computer? Can't I do everything with the Windows computer? And yes, of course you can, but there is a demo I want to do that requires a Linux computer, or is a lot easier, I should say, with a Linux computer. And my own workshop computer, of course, is a Linux box, but it doesn't have a Wi-Fi adapter. So I thought, well, a Raspberry Pi 3 is a Wi-Fi computer, and it's Linux, so why not use that? So we're going to be using this for one of the experiments as well. So now that you've seen my test setup, the first thing to do is to power up the Wi-Fi stepper, and then to go over to the Windows computer here, connect to the Wi-Fi, and load the web-based interface. And so let me show you that now. Alright, so the first step, of course, is to power up the Wi-Fi stepper board. So I'm going to do that right now. I'm going to give it 12 volts. Now, it's a bit difficult to see on camera, but there's a couple of LEDs over here. There's a green one which indicates power, and an orange one that indicates Wi-Fi activity. And so now I'm going to move over to the computer and connect to the network. So let's take a look at my networks. And this is it over here, WSX100-AP is its SSID. I'll connect to that. There's no passkey or password involved in this network. Okay, so we're connected right now. Now, of course, after you've established a connection, you can go back and add a password or passkey to secure the network, but I'm going to do my experiments without that. So let's move over to another desktop where I've got a web browser, and we'll go to the URL 192.168.4.1. And that brings up the Wi-Fi Stepper web-based interface. So now that we've done that, we're going to look at the web-based interface, and then we're going to use it to control the stepper motor. Now here's the web-based interface for the Wi-Fi Stepper controller. Now the settings page is the page it defaults to when you first go there, and you go there by going to 192.168.4.1. The settings page are the settings for the ESP8266, so these are all the network connection settings. You can change the mode, although I would leave that at access point. Then you can change the SSID if you wish, and you can also enable a password, which is a good idea. Now, I'm not going to do that for these demonstrations, but when I put this into actual use later on, I'm certainly going to do it. You can also hide the SSID if you wish. On the browser and API interface, you can enable HTTPS and add some authentication for that. And then you can reset the motor or do a factory reset of the entire device. Now below this we have a documentation section, and as you can imagine, this contains some documentation about hooking up a stepper motor to the controller and some issues about high voltage and hardware reset. The troubleshooting section gives you some troubleshooting tips that you can follow if you're having difficulties getting something to work. And the About section is a typical About section. It tells you about Good Robotics and gives you a link off to the crowdfunding campaign. Of course, if you don't have another Wi-Fi connection, or another network connection rather, on your computer, that link isn't going to work, because currently I'm disconnected to the stepper motor controller. The Quick Start is where most of the action is. Now under Quick Start, you can set up a number of different parameters for the stepper motor itself. You can select which mode you want to use, servo control, speed control, or external step clock. I'm going to cover all three of those modes in a few moments. There are some flags that get indicated over here if there's some form of an error, command error, overcurrent, under voltage, or thermal errors. Now you'll also get a red light on the stepper controller if you get one of these flags raised. And then there are some motor configuration parameters that you can set if you need to for your motor. You can also go into advanced settings for both the current mode and the voltage mode. I'm going to leave these as they are, but you can fine-tune them for your own application if you wish. And then we have the quick code section, which I will cover a little bit later in this video. This basically gives you some code samples in Bash and Python that you can use to write code to control the stepper motor from an application without using the web-based interface. So there you have it, the web-based interface. Now that we've seen this, let's start using our Wi-Fi stepper motor controller. So now that we've looked at the web-based interface, it's time to put the Wi-Fi stepper controller through its paces. Now when we looked at the web-based interface, you no doubt noticed that the motor could be driven in a number of different modes. There was speed control mode, servo control mode, and external step clock mode, and we're going to cover all three of those. There also was the selection between current and voltage control, which can make a very big difference in the performance of your stepper motor, and we'll examine that as well. So let's begin by looking at speed control mode. So we're going to start off in speed control. Now I've used the drop down here to select speed control, and it's telling me I'm using a NEMA 17 style motor with 12 volts input, and currently I'm using current control. We'll examine voltage control in a moment. Now I've got the speed set at 30 RPM, and I'm microstepping at 1/16th, which is the highest resolution, but you can change the resolution here if you wish. I'm going to keep it at 1/16th. And if I want to go forward, I'll just hit the forward button, and you'll observe my motor is turning forward. Now I can hit the reverse button and send the motor around in the other direction. And of course I can stop it as well. Now over here we have a switch for both hard stop and high Z stop. Z stands for impedance. Now what I want you to look at right now is on my power supply at the bottom, you can see the amount of current that I'm consuming, and it's not a great deal. This is kind of the idle current right now. Now watch what happens when I put this into hard stop mode. And I'll spin the motor and stop it. And now look at how much current I'm consuming. In hard stop mode, the shaft of the motor is being held in place right now. It's got current in it, so the motor's getting kind of warm. But this is something you do if you want to hold something in position when it's stopped. When you're at high Z stop, let me spin the motor again and stop it. You'll notice again I'm drawing hardly any current, and I can freely spin the shaft on the motor if I wish. And so these are two different stop modes. Now before we move on, I want to examine two other things in speed control. The next one being the stop on switch. Now for this demonstration, I want to draw your attention to this blue wire that I've connected to the Wi-Fi Stepper board. I've connected this to the SW input, and SW is just an abbreviation for switch. This input is pulled high, but I can take it low by just attaching it to the ground rail that I've got over here, because this is grounded to the same ground that the board is using. So I'm just going to leave it aside for now. And on the interface, you will notice there's a function that says stop on switch. And what that will do is it will stop the motor when that line goes low. When the switch is pulled low, the motor will stop. So I'm going to set the motor in motion again. And once I ground it, as you can see, the motor is stopped. Now if I remove the ground, the motor is still stopped. I have to start it again. This effectively is very similar to hitting the stop button over here on the web-based interface. So I'll do this in reverse, just to show you that this works in both directions. And it does. And what this would be very useful for would be for a limit switch, either a physical switch or an optical switch driving a transistor, that could be used when you're moving a mechanism and want to know when it's got to the end of its travel. So a very useful feature indeed. I've got one more feature to show you on the speed control before we move on and look at the servo control. Now one final concept I want to go over, which actually affects all of the different control modes, is whether you're using current or voltage control, which you can set over here. Now the difference being, in current control mode, the amount of current is regulated into the stepper motor coils, not the amount of voltage. And so you could very well be putting more than the 12 volts that my stepper motor is rated at, as long as you don't exceed a maximum amount of current. Now in this mode, the stepper motor is going to give you its maximum torque and maximum holding power. However, of course, it's going to take a lot more current, and it will build up a lot more heat. In voltage control mode, you are regulating the voltage to the voltage that the stepper motor requires, which in my case is 12 volts. And so the amount of current will be far less. Now, if you go down in the interface over here and go to Show Advanced Settings, you can actually set the current control mode settings. I'm just using the ones that came by default, but you can set those if you wish. Now what I want you to observe is my power supply here. The very bottom of the supply shows the amount of current that I'm drawing, and this just indicates I'm sending it 12 volts. And so watch the current. Now right now everything is idle, so it's not taking that much current, but I'm in current control mode. And so let's start the motor and take a look at the amount of current I'm drawing. That's quite a bit. That's over half an ampere of current this little stepper motor is drawing. And the torque on this is now very, very high. It would be very difficult for me to stop this. Now let's stop the motor. And now let's switch to voltage control. And you'll observe a couple of things. Let's start the motor again. Now it's at the same speed and step rate, but look at the amount of current I'm drawing. It's a lot less current. And there's not quite as much torque in the motor though. I can stop it a lot easier than I could in current control mode. The motor is also, as you'll probably notice, a lot more silent than it was in current control mode. So voltage control mode is very useful if you want to run the motor and consume very little current, and also to make the motor run silent, whereas current control mode is definitely useful when you want to get the maximum amount of torque out of your motor, but of course you're going to consume more electricity. So having said that, let's move on. So now we've seen the speed control mode, and we also saw the different effects between using it in voltage control and current control. And we also saw how the stop switch works. It's time to move on to another control mode, and this time we're going to look at servo control mode. Now, as the name would imply, it allows you to use the stepper motor a little bit like a servo motor. It's not exactly like a servo motor, and in some respects it's actually better than a servo. In servo control mode, you can move the motor shaft a specific number of degrees and then it will stop, so you can use it quite a bit like a servo. You can use it with the web-based interface either by inputting the number of degrees that you want to move the shaft, or by using the graphical user interface and actually dragging the motor shaft into the position you want to put it into. So it's quite versatile. So let's take a look at that right now. Now, the best way of understanding how the motor controller operates in servo control is to observe the position of the motor shaft as I manipulate it with the web-based interface. So you'll notice it's facing straight backwards right now. And I'm going to grab the handle and move it to the 90-degree position, roughly. And as you can see, the motor corresponds with the position that I've selected on the web-based interface, and I can move it back and forward at will. I can also use this box over here to set the position, so I can set it back to 0 if I wish, or if I wish perhaps to go to 180. And the motor moves exactly where I want it to. And so as you can see, this would be a very useful mode if you wanted to precisely position the servo shaft in a specific angle. Okay, we've seen both speed control mode and servo control mode, but there's one more mode we need to look at, and that's external step clock mode. Now, the external step clock, as the name might imply, allows you to use an external clock source to step the motor. And this external clock source just needs to be a 3.3 volt logic signal. So you could get that from something else like another microcontroller, perhaps an Arduino, that could send out the pulse. If it's a 5 volt pulse, you could use a logic level converter to change it over. I'm going to be using a signal generator actually as my source of pulses. And so I've got a little experiment set up over here to show you external step clock mode. So let's go take a look at that right now. So here I have the web-based interface set to external step clock mode, and it's still under current control. Now, the only controls we'll need to be familiar with here are these down here, the start and the stop controls. Right now it's in a stopped mode, but first, before we start it, I want to show you my test setup over here. Now, as you can see, I've brought a signal generator into here, and currently it's set for a 1 Hertz square wave at 3.3 volts, so it's sending out a pulse every second. And I've got that connected into the step input on the Wi-Fi stepper. That's what this yellow wire is here, and of course the other end is just my ground. And I've still got the switch connection over here. I'm going to demonstrate what that does in this mode in a few moments, but first let's start it right now. So I'm going to hit the start button on the web-based interface, and you'll notice that I'm in microstep 1-to-1 mode. So every pulse is making a step on the stepper motor. And if you can see the motor, it is slowly moving right now. Now I'll increase the frequency here. So now I'm at 10 Hertz. And every pulse is stepping the motor right now. Now let me stop this just for a second. And I'm going to set this over here to 16th step mode. And we'll start it again. Now it's 16th step mode, of course it's moving very slow. So let's bring the frequency up quite a bit. This is at 64 Hertz right now. So basically 64 Hertz divided by 16, it's basically stepping like about one step is doing about 1/4 of a second over here. Okay, so you can see how that works. Now the next thing I want to demonstrate is what happens with this wire over here, the external switch wire. Now the function of the SW input on the Wi-Fi stepper is a bit different in external step clock mode than it is in speed control mode. Now if we go into the interface, we have a checkbox that says direction on SW, and if we highlight this question mark, it tells us it chooses the step direction from reading the SW pin. So I'm going to check that right now. I'm going to run this. Now right now I'm still at 1/16th microstep, and I've set my oscillator now to 160 Hertz, so I'm feeding it a 160 Hertz square wave. And you can see right now the motor is spinning counterclockwise. Now watch what happens when I ground this input. And you'll notice that the motor changes direction. Now it's internally pulled high, so I don't need to use the positive rail, but I could if I want to. So when I'm putting 3.3 volts into here, or no voltage because of the internal pull-up, it spins counterclockwise. And when I ground it, it goes clockwise. And so there's a simple method for using an external logic controller, an external switch, to control the direction of the motor when you're in external step clock mode. So now we've looked at the 3 different control modes that we can use with the web-based interface to control the Wi-Fi stepper. But there's another way that we can control the Wi-Fi stepper, and it doesn't even require the web-based interface. We can control the Wi-Fi stepper with a computer that's Wi-Fi capable using a script running on that computer, and the Wi-Fi stepper supports 2 different types of scripts: Bash scripts and Python scripts. Now, as I said at the beginning of the video, I have a pre-release version of the Wi-Fi stepper board, and currently my version only supports the Bash scripts, so I can't show you the Python scripts. So I'm going to show you the Bash scripts. Now, you may or may not be familiar with Bash scripts. Bash scripts have been around for a long time, like about 30 years, and they essentially let you run any command that you can type at the command line in a script, and they're very useful for automating things. Now, they work best on a Linux command line, and as I said earlier, I brought a Raspberry Pi into the picture so I could demonstrate this. So I'm going to show you how I hook up the Pi, connect it to the Wi-Fi stepper, and get it prepared to run some Bash scripts. And then I'll show you a utility that's already built into the web-based interface that simplifies creating a Bash script. We'll write a script and we'll use it to run our motor. So let's go on and do that now. Alright, so I've booted up my Raspberry Pi and I'm on my Raspbian desktop. Now, before I get started, I actually need to be connected to the internet in order to install something called JQ. Now, JQ is a command line JSON processor. If you're not familiar with JSON, it's a text-based format that allows computers to communicate with each other. In many respects, it's similar to XML. JSON stands for JavaScript Object Notation. Now, in order to install JQ, I naturally need to be on the internet. So So if you're using something like a Raspberry Pi 0W or WH, you only have one connectivity option, and that's the Wi-Fi. And if that's the case, you're going to need to connect your Wi-Fi first to your own network and then go and install JQ, and then you can connect up to the Wi-Fi Stepper. Now I'm using a Raspberry Pi 3B Plus, so I can be connected to both. So right now I have my Wi-Fi connected to the WSX100, but I've also got an Ethernet cable plugged into the device, so I can be on the internet as well. Essentially, I've got two networks attached to this Raspberry Pi. Now, to install JQ, you're going to need to open up the terminal to get at the command line. And at the command line, you're going to type sudo apt-get install JQ. Now when I do this, it's going to just tell me that I already have JQ installed. But when you do it, it will probably prompt you for a password. Now the password is for your Raspberry Pi super user, and unless you've changed it, the password is going to be Raspberry. After that, it will go through the steps of installing JQ, and JQ does take a little bit of time to install, so you're going to need to wait until that finishes. After that, if you're using a Raspberry Pi 0W or WH, you can disconnect from your local area network, and then you can connect up to the Wi-Fi Stepper using the Wi-Fi over here. Again, I've already done that on mine. And once you've done all this, you can probably just leave the command line window open. I'm just going to minimize it because we're going to be using it later. So the next thing you're going to do is you're going to want to connect to the Wi-Fi Stepper. And again, you'll open up the web browser, the Chromium browser that comes with the Raspberry Pi desktop. And you're going to go to 192.168.4.1. And we'll get into the quick start. Now, what I'm going to be doing is I'm going to actually be doing a sequence here. In my case, I'm in servo control. I'm just going to move the motor, and then after that, I'm going to get some scripting information from the bottom over here. If you scroll down here, you'll see in this quick code, there's Bash and Python. I'm going to take some Bash scripting information. I'm going to copy that into a text editor, and then I'm going to edit it slightly and save it as a Bash script. And from then on, I can just run it from the command line without the web-based interface, and it will move the motor in the same direction. So I'm going to show you that right now. So now that I've installed JQ, I'm ready to start creating a Bash script. Now I've opened up the web-based interface for the stepper motor controller. As before, it is at 192.168.4.1. And I've put it into servo control mode under current control. Now that was just for this particular test. You could choose a different mode and the principle will be the same. Now what I'm going to do first is I'm going to move my motor. So I'm going to move it 180 degrees. And as you see, the motor moved 180 degrees. And now I'm going to go down here where it says quick code. Now I've got a Bash and a Python tab over here. Now as I have a preliminary version of the stepper controller, only the Bash is functioning on mine, but by the time that you get this, the Python will also function in a similar fashion. So I'm going to copy this code. I'm going to open up a text editor. Now I'm using Genie. Genie is one of my favorite text editors actually, and it's included with Raspbian, but you could use another editor if you want. If you want to use Genie, just go into the programming section in the Raspbian menu and you will see it over here. I'm going to paste my code into Genie. And I'm going to save the code. Now I could name it anything I want, but I need to end it with a .sh in order to be a Bash file. So now that I've saved the code and told Genie what type of code it is, you'll notice that it's done some text highlighting to make it easier to work with. Now this code is actually got too much in it. It's got something for all of the different functions that the Wi-Fi Stepper can do, and I only want to do the 180 degree thing. So what I'm going to do is I'm going to remove the 0 position. I'm going to keep the servo commands. I'm going to remove the speed, the step clock, and the stop. And so now basically my code is going to set everything up. It's going to write the motor configuration. It's going to have a curl string over here. It's going to read the motor configuration. It's going to send my servo command, and you'll notice my servo command has angle equals 180 in it, and this is the curl string it's going to send out. And then it'll read the status back and read the state back, and that's what comes back with JQ, as you'll notice over here. And so now I'm going to save this. And I'm going to go now onto my terminal. Now because I saved it in the Pi directory, my terminal's in the right place, and if I do an ls, you can see that stepper180.sh is over here. You'll notice, however, that unlike this step 180, which is an earlier attempt I made at this, it is not highlighted in green, and that's because it's not executable yet. I have to change that so that it is. So what you do is type in chmod, and a space, and a plus X to make it executable, and then the name of the file. And do that, and now the file is executable. If I list it again, you'll notice now it is in bright green. And in order to run this file, first thing I want to do is go back here, clear that flag, and reset the position of my stepper, and set myself back to 0 as well too. I just want to set everything so that it is as it was when I captured this. And you'll do a dot and a slash, and then the name of the file. And you'll notice that the motor now moved 180 degrees. So this is a simple demonstration on how you would create a bash file using the web-based interface. And now I can step the motor 180 degrees without actually having to use the web-based interface. And I could call this bash file from another program. And so this is a very versatile utility. Alright, well that about wraps it up for my look at the Wi-Fi Stepper controller. I'd like to thank Andrew over at Good Robotics for sending me this preliminary version of it. I found it to be a really innovative and well-designed product that I think has a lot of applications not only in robotics, but all sorts of remote control and IoT apps could benefit from something like this. Now, if you're watching this video when I first released it, you will find this device on the CrowdSupply crowdfunding site. And you can go there for more information about the device, as well as information about ordering one for yourself. Now, if you'd also like some more information about the Wi-Fi Stepper, there's an article that accompanies this video you'll find on the dronebotworkshop.com website. While you're on the website, I would really appreciate it if you would subscribe to my newsletter if you haven't done so already. My newsletter is not a sales letter. It's a way of keeping in touch with you, keeping you up to date as to what I'm doing here in the workshop, and most importantly, soliciting your opinion as to what videos and articles you would like me to create for you, because creating content that's relative to you is very, very important to me. I would also appreciate it, if you haven't done so already, if you would subscribe to the YouTube channel. It means a lot to me when I get new subscribers, and it's just a matter of clicking the button below this video to do that. So until the next time, please take care of yourselves, and I hope to see you very soon here in the workshop. Goodbye for now.